Okay, 311. Let's do the homework. Number 1 is asking us, is x plus 3 a factor of f of x? And f of x is this cubic polynomial here. Show or explain your thinking. You guys, you got options here. We've got options. So we can either divide, or we can use the remainder theorem. So here's the question. In my opinion, they're not too different, okay? However, the big question is, do I need to find more factors? If you do, divide. But if you only want to check if this is a factor and nothing else is like going to be coming up after that, you can just do remainder theorem. So here's what remainder theorem says. Remainder theorem says that if x plus 3 is a factor, then negative 3 should make that function 0, which means that f of negative 3 should equal 0. So let's find out what f of negative 3 is. And the way we do that is we plug it in every time we see an x in here. So negative 3 cubed minus 3 times negative 3 squared minus 10 times negative 3 plus 24. So now you can either type all of this into your calculator and press enter. Just don't forget, every set of parentheses I put matters. You need them all. Or since I don't have one, I'll do it by hand. This is negative 27 minus 27 plus 30 plus 24. And then this is negative 54. And this is this is positive 54. And this is negative 54, which means that it does equal 0. So yes. And this is my thinking. Okay, x plus 1 is a factor. They're telling me it is. Select all the other polynomial factors. So guys, don't get confused. There is no good that's going to come from me plugging in negative 1 and using the remainder theorem here. All it's going to do is get me a 0 and show me that x plus 1 is a factor, which the problem told me, so I already knew it. This is a situation where I need more factors. So when you need more factors, then divide. Okay. Where should we do this? Because there isn't exactly a lot of space. Let's do it up here. We'll go 1, 2. Do we need more here? Maybe more. 1, 2, 3, 4. And then we're going to put x plus 1 on the side, remember? And then we're going to start with x to the 4th in the first box. And let's do it. X goes into x to the 4th, x cubed times. And if that's an x cubed, then this is x cubed. So, okay, let me explain a little bit just in case, but you can go back to the old videos. So if this is an x to the 4th, this had to be an x to the 3rd to multiply together to make that x to the 4th. And now once there's an x to the 3rd there, and that's a 1, I gotta multiply them together to get this box. Now comes the investigation. Because what I need is a negative 3x cubed. What I've got is a positive x cubed. So I need a negative 3. Let me show you. I need a negative 3, but I have a positive 1. So I must subtract my positive 1. That's going to make negative 4. That's what I need to do. I need to subtract 4x cubed. And then 1 minus 4 is the negative 3. So these two are like terms that combine to make what I want. So what you're doing is figuring out what other like term there was before that combined with this to then simplify to make this polynomial like this. Now that there's a negative 4x cubed here, that has to be a negative 4x squared. Multiplies by x to make that. And then negative 4x squared times 1 is negative 4x squared. And now we play detective again. I have a negative 4x squared. What I want is a negative 41x squared. So that means that I need 37 more negative x squareds, if that makes sense. That's how my brain sees it, is I already have 4 negatives. I want 41 negatives, so I need 37 more negatives. However, you can do the same trick as before. You can take what we want to achieve, which is a negative 41, and you can subtract what we have, which is a negative 4. Press enter, and it will get you negative 37. Okay, that makes a negative 37x up here, which makes a negative 37x down here. And now I have a negative 37x, but what I want is a positive 3. So I need 40 x's to do that. All right. But again, you can come here and you can say, I want 3. I will subtract what I have, which is a negative 37, and this becomes 40. And that makes this 40, which makes this 40, which now a 40 here and a 40 here means that there's no remainder, which shouldn't be surprising because they told me that x plus 1 was a factor. So this should have happened. This is actually confirmation that I did things right. And now let's understand what we did. We took this big 4th degree polynomial that they gave us, divided a factor into it, and got ourselves a slightly more manageable, a smaller polynomial right here. That's a cubic polynomial, okay? So now we have a cubic polynomial. Okay, here, let me rewrite. I want to make sure we know exactly what we are doing. This is g of x. I now know that g of x equals x plus 1 times x cubed minus 4x squared minus 37x plus 40. Okay. Unfortunately, this cubic function is not a quadratic, okay, and it doesn't factor by grouping. I can't factor it. So what does that leave us? It leaves us with needing to divide this one more time to drop the degree down to a 2. But unfortunately, they only gave me one of the factors. They didn't give me a second one. So I kind of have to take a shot in the dark and hope that I get lucky. It's not the best situation, but it is a very common math situation, okay, where we just have to guess and check for a little until we can get ourselves where we're going. So let's do this. We now want to pick one to divide, all right? I usually am skeptical that the very first one will work out, so let's try the second one. All right, if I put x, now don't go dividing it into x to the 4th, all right? Divide it into the new, smaller, more manageable polynomial we got. Because we divided the 4th degree, we ended up with a 3rd degree. If we divide the 3rd degree, we'll end up with a 2nd degree, which is quadratic, which we can solve without guessing. So I'm going to drop x cubed in here. And remember, this is now the function we're dividing. So x goes into x cubed, x squared times 2 is 2x squared. Now I have a 2x squared. I want a negative 4x squared. So this is minus 6x squared. And I'm not going to do this part again, but you feel free to do it if it's difficult to figure out how I got the negative 6x squared. If there's a negative 6x squared there, this is a negative 6x. Multiply it, this is a negative 12x. This is a negative 12, but what I want is a negative 37. So I already have 12 negatives. I need another 15 negatives. No, that's 27. Just kidding. I need another 25 negatives to make negative 37. And I can tell now that this is probably not going to work out. This is going to get me a negative 25 up here, multiplied to get me a negative 50 here, and there is a quite hefty remainder of 90, because I have negative 50, but I should have had positive 40, so the difference there is 90, which it always stings more. Whether it's any number other than 0, it didn't work out, but when it's a big number for some reason, it stings a little more. That didn't work. I wonder if the negative would have worked, though. Maybe some of these signs would have came out better. Maybe I was wrong to discount the first one. Who knows? Let's see. Negative 2x squared. It's a negative 2. I need it to be negative 4, so I need another negative 2. So this is a negative 2x. So you guys go ahead and divide. Okay, my hope is that you know how to divide based on the explanations I've given in the previous videos and the previous examples, and that you don't have to watch me do it, that you can try some yourself, okay? This is a positive 4x. I need a negative 37. So that means that I need negative, that's not going to be good, 41x. Right? That's negative 37. So then this is a negative 41, which then is not good. It's not good. The 2's, both of the 2's burned me. They're not good. I'm not going to get a 40 in that spot. Okay, let's keep it going. All right, guys, I'm going to try x minus 8 and hope they're not so cruel to make me do this for a long time. X squared, negative 8x squared. I need a positive 4x squared. So then I need here a 4x. And then this is a negative 32x. Ooh, this is looking a little better. And so then this is a negative 5x, which means this is a negative 5, which means this is a positive 40. Woo! All right. Okay, you guys. X minus 8 worked. I divided it. I got no remainder. It's fantastic. So x minus 8 is a factor. Let's go ahead and pick it. But even better than that, I've got this quadratic polynomial now where I can factor to get what multiplies to negative 4 and adds to, what multiplies to negative 5 and adds to 4. So that's going to be our positive 5 and our negative 1. And that means that x plus 5 and x minus 1 are also factors. These two. Okay, so you guys see, if we can get it down to quadratic, we can factor. And even if it doesn't factor, we can use the quadratic formula. Don't forget that. Or completing the square is not always terrible. Okay, let's keep going now. Here's a graph of the polynomial function of h of x. What's the remainder when h of x is divided by x minus 1? They want to know if you understand how this stuff works. Okay, a factor of x minus 1 is a function value of 1, okay, positive 1. Let's see what f of 1 is, meaning let's see what y is when x is 1. So when x is 1, y is right here at negative 1. And according to the remainder theorem, this is what the remainder would be if we divided h of x by x minus 1. Okay? Let's do it again. That's a x plus 3, which means the function value we want to investigate is, negative 3. Okay? So this means what is y when x is negative 3? So we go to negative 1, 2, 3, and look at the function right here at 0. So that means that the remainder is 0, which means that x minus 3 is a factor of h of x, whatever h of x is, okay? What is the remainder when blah, 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 blah is divided by blah? So you guys, choices. All they want to know is the remainder. I don't need to find further factors, okay? So I can either divide like these, or I can use the remainder theorem to see what f of 3 is, because if it's negative 3 here, then it's positive 3 going into the function. Let's see what f of 3 is. 2 times 3 to the 4th minus 5 times 3 cubed plus 7 times 3 squared minus 11 times 3 plus 3. Now, if you have a calculator, this is great. Type it all in exactly as it appears, parentheses and all. You're going to get the answer super quickly, okay? I'm thinking since I don't have a calculator, division would have been easier, but I'm committed. So 3 to the 4th is 81, and then times 2 is 162. 3 cubed is 27, which times 5 is 135. I buy that. Okay. 3 squared is 9. 9 times 7 is 63. 33 and 3. Okay. Let's see. These two will get me a 27. Yeah, I think they do. And then I add 63, subtract 33 from 63, and this is 30, plus 3 is 33, and add those, and that is 50, 60. I am curious if I did that right, because I'm so tired, you guys, and my brain wasn't really functioning properly during that. I don't want to be wrong and send you guys on a chase to see if I'm wrong or if you're wrong, like that problem from the previous video did, which I later, by the way, found out that if you look close enough, their little stupid graph dips ever so slightly below the x-axis. Whatever. Okay, 2x cubed, negative 6x cubed. And then it's a negative 6. I want a negative 5, so I need a 1. X squared. Negative 3x squared. So I need 10. And then this makes this a 10x, which means this is a negative 30x. But then I need like 19x. And that's not good. Oh, wait, maybe it is good. Let's not get ahead of ourselves. That's 19. And then 19 times 3 is 60 minus 3, which is 57. Negative. And then to get from a negative 57 to a positive 3, I need a 60. Wow, look at that. I was right. And there it is. You have it both ways. You decide what's better. 100%, if you've got a calculator, this is better. If you don't have a calculator, possibly this is better. I don't know. You decide. Okay. If x minus 2 is a factor of blah, 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 what is the value of a? Okay. Let's talk about this. Because we need to look at this. The rules of math, they don't change for funny looking. So to see if that's a factor, we still have the same two options. We can either divide or we can use a remainder theorem. And division was my first instinct, but then I'm thinking, why not remainder theorem? Let's give that a shot. I'm so curious. The algebra is going to be fun. This is going to be a 2, right? Because x minus 2 makes the 0 be 2. And they're telling me it is a factor. So that means that if I find j of 2, it must equal 0. Must equal 0. Remember that. j of 2 equals 0. So let's see what j of 2 is. It's 2 to the 4th minus 3 times 2 to the 3rd plus a times 2 squared minus 16 times 2 plus 14. Did you see how that a did not make me skip a beat? I just kept going, okay? We're going to do what we would have done despite the funny looking, all right? 2 to the 4th is 16. 2 to the 3rd is 8 times negative 3 is negative 24. This right here is 4a. And this is minus 32. And that's plus 14. God, I need to get a calculator before I come over here from now on. Okay, let's see what we've got. We have a 16 plus a 14. That's 30. And then minus a 32 is a negative 2. Minus a 24 is a negative 26. Can't be. Does it come out that ugly, or am I tripping? 16 plus 14 is 30. Minus 32 is a negative 2. And then minus 24 is negative 26. Okay, so I'm going to trust it. I have 4a minus 26 is what this all simplifies to. And that needs to equal 0. Which means that 4a must equal 26. Which means that a must equal 26 divided by 4. Which is 13 divided by 2. That's what a should be. But again, since I don't trust my brain without a calculator today, let's also do it this way, where I divide by x minus 2. I'm going to do it in blue so it doesn't get all confused with all the writing I already have going on here. X minus 2. We'll divide it into x4. Okay, this is x3 divided negative 2x cubed, and then it's a negative 2x cubed, so I need a negative x cubed, and then this is an x squared negative, then this is a positive 2x squared. Okay, I need it to be an ax squared. So how about this? Let's try to work backwards a little. A student tipped me off to this because we know that this is a factor, which means we know that over here we should get 14. We should not have a remainder. So now if that's 14, this is negative 7. So then this is negative 7x. And then if that's negative 7x, but I have a negative 16x, and this must be a negative 9x. So if this is a negative 9x, then this is a positive 9/2 x. That would multiply by that to make that. That makes this 9/2 x squared. And then that would mean, oh my God, it works out. That would mean that this and this must add up together because they're like terms. So 2 plus 9/2 must add, so that's 4/2 plus 9/2, getting a common denominator, is 13/2. This should be the coefficient of x squared, which means this should be a. So it works out both ways. Whichever way you do it, it works out. Okay. Let's see what else they say. Create a polynomial p of x such that p of x divided by this equals this. Ooh. Okay, I'm excited and actually a little surprised because these questions are usually really hard. They're saying that p of x divided by x minus 4 equals that 2x squared plus 3x minus 1 plus 5 over x minus 4. Okay, what I want to do, you guys, what I want to do is just multiply both sides by x minus 4. Watch. if I just multiply both sides by x minus 4, this x minus 4 cancels that x minus 4, and I get p of x equals whatever this is. So then all I gotta do is take this x minus 4 and distribute it into each of these terms. Meaning, I need 2x squared times x minus 4. And I need 3x times x minus 4. And I need 1 times x minus 4. And I need 5 over x minus 4 times x minus 4. And that means, right here, when I distribute, I get 2x to the third minus 8x squared plus, now I distribute again, 3x squared minus 12x minus, distribute again, x plus 4 plus, and look, you guys, the one that probably gave you the most anxiety is the easiest one. This cancels that out, and it's just 5. And now let's go find like terms. So there's only one x cubed, but here's 2x squareds. Here is my x terms and my constant terms. So p of x must equal 2x cubed minus 5x squared minus 13x plus 9. Okay? I bet there's another way. I bet the other way is to say that p of x was a function inside the box. It got divided by x minus 4. The remainder came out to be 5. And the answer came out to be 2x squared plus 3x minus 1 with a remainder of 5. And then work it backwards. So if there's a 2x squared there and an x there, then this must be a 2x. And cubed, sorry, we're multiplying. Oh my god, I went to divide. Remember, outside of the box multiplies. Then this times this is a negative 8x squared. Oh my gosh, look at me getting all the same stuff right now as I got. I wonder if that means that this times this will be a 3x squared. And this times this will be a negative 12x. And then this times this will be a negative x. And then this times this will be a positive 4. And then with that positive 5. And then when we go and combine our like terms, we get the exact same answer. We literally did the exact same work. However, if you were like, what is she doing here? I bet you find this a lot easier to follow, and it's the exact same thing. Another reason this box is fantastic, you guys. Fantastic. Okay. And now we're in the spiral review of determining the zeros of each polynomial, and because this is oh so important for this test, I'm going to do it. All right, this first one, you guys, please note how this is a closet quadratic, all right? Because I have an exponent here, then this exponent is half of that exponent, and then at the end I have a constant. That means that if the 14 and the 5 play nice, I can factor this like any old quadratic. Here's how it goes. If I can find two numbers and multiply to negative 14 and add to 5, which 7 and 2 look hecka promising if the 2 is negative, then I'm in business, all right? So what does this mean? This means that this polynomial right here actually factors into x squared. Remember, what goes in the parentheses will match what the middle term's variable situation is in this scenario of the exponent, half the exponent, no variable at all. And then this is x squared plus 7, and then x squared minus 2. And then they asked me for the zeros, which means I got to take each of these factors, x squared plus 7, and set it equal to 0. I also take x squared minus 2, set it equal to 0, and I solve. Step 1, subtract the 7 from both sides. X squared equals negative 7. Over here, add the 2 to both sides. X squared equals 2. I'm at the stage where I got to square root both sides on all of these. Here, remember, when you square root both sides, you must get a plus or minus. Write it down immediately. Here we have the square root of 7i. And over here I have plus or minus still, just root 2. You guys, when they come out ugly like that, there's nothing we can do. But a negative inside the radical becomes an I outside the radical. And this is the 4 zeros that this function has. All right, so plus or minus root 7i and plus or minus root 2. You can write them separately if you want, but you don't have to. Like you can write 7i, rad 7i, negative rad 7i, positive rad 2, negative rad 2. Okay, now this one. Let's get to factoring. X to the fourth minus 81 is the difference of squares. So it will factor into the square root of the first one, which is x squared, and the square root of the second one, which is 9, and one gets a plus and one gets a minus. And then we look at what we have left to see if it factors. I didn't say this, but I did look at x squared plus 7 and x squared minus 2 to see if they factor further. And because they did not, I solved them this way. Over here, x squared plus 9 does not factor further, but x squared minus 9 does. That's the difference of squares again. So it's the square root of the first one, which is just x, the square root of the second one, which is 3. One gets a plus, one gets a minus. So x to the fourth minus 81 actually factors all the way into this. And then now I go solve them all. All right. Lucky for me, I can tell from x plus 3 that negative 3 is a 0. I can tell from x minus 3 that positive 3 is a 0. And then with the x squared plus 9, we set it equal to 0. And we solve it. So we subtract the 9. It's going to look hecka familiar to those. We square root. We plus or minus. We 3i. Square root of 9 is 3. Negative in the radical is an I. So we also have plus or minus 3i. So 3i and negative 3i. I listed it out this time. You could have also done plus or minus 3, plus or minus 3i. And now this guy. Okay. This doesn't factor. And it's a cubic function. So that means I need to find a 0. I need to find a factor to divide into this to get a quadratic that I can hope to solve, okay? Well, I don't have one. They didn't give me one, so I got to guess and check. And if you're going, oh my God, what? I have to guess and check blind on this guy? You actually don't have to guess and check completely blind, because understand that if we go to the box with x cubed and some factor, x and something, okay? If this is a factor, what I should get in this last box is a 25, because it needs to match that to have no remainder. Which means with a 25 right here, I don't have a ton of options for what can go here, because there aren't that many numbers that divide into 25. It's really just 1, 5, and 25 itself, all right? So frankly, I mean, I'm kind of guess and checking with technically only 6 numbers. Positive 1 or negative 1, positive 5 or negative 5, and then positive 25 or negative 25. So there's only 6 really possibilities of what could go nicely here. And we just try one. And to be honest, I should probably just start with 1, but for some reason I just want to start with 5. Actually, I think 5 is going to be excessive. Whatever, let's do it. Follow your heart, guys. 5x squared. Okay, if this is a 5x squared, I need an 11x squared, so I need a 6x squared here, which means this is a 6x, and then this multiplies to become 30x. And if this is a 30x, and that's a 35, then I need a 5x. And look what happens when you follow your heart, guys. Sometimes everything works out nicely. Sometimes. So it worked. X plus 5 was a factor. That means that I just discovered that this cubic polynomial factors into x plus 5 and x squared plus 6x plus 5. And then this is a quadratic, x squared plus 6x plus 5, that I can attempt to factor as long as I can find 2 numbers and multiply to 5 and add to 6. And that's 5 and 1, which means that this is x plus 5, another x plus 5, and an x plus 1. That means that the zeros of this function are only 5 and 1. And this may sound contradictory to what I told you guys, that a third degree polynomial would have 3 zeros. And you're going, this one only had 2. Well, multiplicity kind of counts, you guys. This is a multiplicity of 2. 5 actually counts twice. We have 5 with a multiplicity of 2. So technically it's almost like 5, 5, and 1. So it does count as 3. 5 is a double 0. Okay. Man, this is fun. Here's a graph of r of x, a 4th degree polynomial. Write an equation. Okay, guys, this is just a game of Clue. Look for clues, you guys. Look for clues, all right? R of x equals. My first clue is, does it equal positive or negative? That's the only thing I really want to know right now. And looking at how this ends up, that means that I am positive. So right here, positive, okay? All right. You could put a positive number there if you want, like a 2 or 5 or 800, okay? But you don't need to put anything, because if you put nothing, that's a positive 1 and it's positive. Just don't put a negative, basically, and we're good, okay? Next, I want to know what factors, like, we could have. So how many factors and what are they is determined by my x-intercepts. So my next clues are my x-intercepts. I have negative 5 as an x-intercept. That means that x plus 5 is a factor. I have 0 as an x-intercept. That means that x by itself is a factor. Or you can think of it as x minus 0. Or just x, all right? And then I have 4 as an x-intercept, which means that x minus 4 is a factor, okay? And then this next clue is going to be the shape right here, right here, right here. If the shape that's inside that little box you draw around your y-intercept, if it looks like a line, then the multiplicity of that 0, meaning the exponent on that factor, is going to be 1. Like here too, all right? Exponent of 1. If it's this parabola looking thing, then that means that the multiplicity or the exponent is a 2, meaning 2. 2. Okay? Okay. And then this problem doesn't cover it, but if we have an x-intercept that we like wiggle through, I don't know why, that just looks hecka like a wiggle to me. If we wiggle through an x-intercept like these, then I would go with a multiplicity of 3 or higher as long as it's odd. And then with this parabola shape too, you can go with a 2 or higher as long as it's even. Okay? But in this particular problem, they tell me this is a 4th degree. So don't get too crazy with these exponents and exceed the degree that we were allowed to have. In our situation, x plus 5 to the first, x to the second, or let's write it x minus 0 to the second, and x minus 4 to the first is already a 1 plus 2 plus 1, which is 4, a 4th degree. Okay? This is cool. It looks a little funny though. So here's how we make it not look funny. X minus 0, that's just x. And it's squared. So we just put that part in the front. And then we put the bigger guys second. And if you want to make it look even more thing, you could leave those ones off. But I would never take off a point because you left the ones there. All right? Okay, man, that was a lot, but I feel like make sure this is important stuff for that test, you guys.